In this video we have a definite integral to evaluate from 0 to pi over 2 of e to the sine of x times cosine of x. You can pause the video here if you want, try it, and I'll be right back. Here we have e to the sine of x. You take the derivative of sine, you get cosine. So that's a pretty good hint that we want a substitution, a u substitution. So let's let u equal to sine x, and du would be the derivative of sine, which is cosine, and then dx. And we can go ahead and proceed and go ahead and find the value of this integral and then use the same limits of integration, or we can change the limits of integration. So that's what I'm going to do here. So here, the way it's set up here, x equals 0, and then the upper limit is x equals pi over 2. So if x equals 0, this would imply over here and this one here, put a 0 where the x is, and these of course are invariants here. Put a 0 there, the sine of 0 is 0. So when x equals 0, u equals to 0. And then for the upper limit, that's at x equal to pi over 2. When x equal to pi over 2, plug it in into our substitution. Get sine of pi over 2 is 1. So this would be u equal to 1. So we can leave everything in terms of the variable u and use those new limits of integration. So this then would be the integral from 0 to 1. And this will then be e, and sine of x then is u. And cosine of x dx, cosine of x dx can be replaced by du. I got everything in terms of u, so now we just do the integration. Pretty straightforward integration with respect to u. So the integral of e to the u is e to the u. Here we don't need a constant of integration. You could put it in there, but when you do the subtraction it cancels, so we usually leave it out. So this is going to be evaluated then from 0 to 1. So put a 1 where the u is, that's e to the 1, or just plain e, minus, and evaluate it at 0, e to the 0 is 1. So the final answer of this definite integral is e, or e to the 1, if you want to put the exponent there, minus 1. Thanks for watching. We'll see you next time.